Section 9.7, Day 2, Graphs of Polar Equations. So we've graphed some basic polar equations in terms of lines and circles, but today we're going to be looking at some special polar graphs. You can use your graphing calculator or you can use the Desmos app to help you graph these. First one we're going to look at is a cardioid. Cardioid is a heart with the center at the pole. So the equations are written as r equals a plus or minus b sine theta, and r equals a plus or minus b cosine of theta. The key here is that a must equal b for this to be a cardioid. So the first example is r equals 2 minus 2 cosine of theta. And if you look on the graphing calculator, we do got to make a couple changes. We need to go to mode and change what we typically have as a function. We want to change it to polar. So make sure, once again, if you're using the graphing calculator, you change it from what you typically have as function to polar graph. You also probably want to make sure that you are in radians. So now when you plug in your equation, you type in 2 minus 2 cosine of theta. So if you're wondering where the theta is, it's the same button that the x was, but now when you press it, because you're in polar form, it will now have the angle theta there. So 2 minus 2 cosine of theta. And then when you go to graph, you can zoom a couple different ways to make it look like it does on the screen here. If you first start off with zoom 6, which is zoom standard, that will get you in your 10 by 10 window. But then if we go to zoom 0, that does a zoom fit, so it fits it nice on the calculator. And then the last one is a zoom 5. The zoom 5 is zoom square, so once you get the zoom fit taken care of, if you do the zoom 5, it'll make it look like the shape that it should in terms of making your graphing calculator square instead of a rectangle on the graph. So you can see right there as to what a cardioid looks like. Once again, the center should be at the pole, so you can see right here that's centered at the pole, and that's what a cardioid looks like. So as long as a is equal to b in those two equations, you will get something similar to this. The next special polar graph that we will be looking at is a Lemniscate without an inner loop. This looks like a heart with a center not at the pole. So once again, if you look at the two equations I have here, they're the same equations we had before. R is equal to a plus or minus b sine theta, and r is equal to a plus or minus b cosine of theta. But on this one, a must be greater than b. So if a is greater than b, then we'll still get the cardioid, but it'll be not centered at the pole, and therefore we call it a Lemniscate without an inner loop. So example 2, you can see that r is equal to 3 plus 2 sine of theta, where the 3 represents the a and the 2 is the b. So 3 is greater than 2, so therefore this satisfies the Lemniscate without the inner loop. So you can see as we plugged in 3 plus 2 sine theta, once again you can use your zoom standard, zoom fit, which is 0, and then zoom 5, which is your zoom square. And you can see once again that it is no longer centered at the pole right here. And once again, this is called a Lemniscate, but it's without an inner loop. So obviously we're going to be looking at one with an inner loop. So as I said, here is a Lemniscate with an inner loop, so it's a heart with a loop. So you can see, as we have done so far, all three of the equations, or all three of the polar graphs have the same equations, but on this one, a must be less than b. A is less than. So kind of an easy way to remember this: if a is less than b, then it has a loop. So less than loop. Alright, so we have r is equal to 2 minus 3 sine of alpha. A is less than b, so it should have a loop centered at the pole, which it does, you can see right there. And so this is a Lemniscate with an inner loop. The next polar graph that we will look at is called a rose. The equation for a rose is different than the first three that we've done. This one is r equals a sine of n theta. So there's no addition or subtraction, it's all multiplication. And r is equal to a cosine of n theta. A cannot equal 0. And a couple things with the n value, if it's even, then we have twice as many petals. If it's odd, then we have exactly that number of petals. So I've gave you two examples here. First one is r is equal to 2 cosine of 4 theta. So the 2 represents the a value, and then the 4 theta here, the 4 represents the n value. So in this case, if n is equal to 4, then that means we have twice as many petals on the rose. So we have 8 petals, and you can see 1, 2, 3, 4, 5, 6, 7, 8 on the rose. And once again, that's twice as many when the n value is even. On 4b, a is still equal to 2. This time n is 5. So if n is an odd number, then that means we will have that many petals on the rose. 1, 2, 3, 4, 5. So the rose is r equals a sine or cosine of n theta. If n is even, you have 2n petals. If n is odd, you have n number of petals. And the last one we're going to look at is called a lemniscate. It's a propeller shaped, definitely a lot different in terms of the equation of the other ones. This one is r squared is equal to a squared sine of 2 theta. Once again, a cannot equal 0, or we can do r squared is equal to a squared times cosine of 2 theta. So for an example, if we have r squared is equal to 4 sine of 2 theta, when we go to graph this in the calculator, we have to rewrite it as the square root. So we would take the square root of both sides, get r is equal to positive 4 sine of 2, or the square root of 4 sine of 2 theta, and the other one would be equal to negative square root of 4 sine of 2 theta. So with this one, we have to make sure that we rewrite it with the r squared. And it's the only one that is written as r squared, so it's an easy one to pick out when we go to identify the differences between these equations. So you can see on the calculator we have the square root of 4 sine of 2 theta, and then the second equation is negative square root of 4 sine of 2 theta. So when you graph them on the calculator, you can see how you get a little propeller shaped figure here, and that is called a lemniscate. And so that is it. Those are the special polar graphs that we are going to look at. Be able to graph them on your calculator, and also be able to identify different equations. So if I write an equation, r is equal to 4 minus 2 sine of theta, which polar equation is that? Or if I say r is equal to 3 cosine of 8 theta, can you identify that? So make sure you can identify the equations and also be able to graph them on your calculator. And just so you know, the first example that I did here would represent which of the different equations we talked about. It would represent a lemison without the inner loop, and then the second one would represent, there's no plus or minus, that's the rose, and since n is 8, it would have 16 petals on it.